Welcome to The Explainer. So, artificial intelligence. It is absolutely the defining technology of our era. I mean, we hear about it constantly, right? It's on the news, it's taking over the workplace, it's in our group chats. But today, we're going to look way past the hype and those flashy headlines. We're going to peel back the layers of this massive buzzword to uncover the precise mechanics of what AI truly is, how it actually functions behind the scenes, and what its rapid evolution means for all of us. Okay, let's dive into this. When you hear the words artificial intelligence, what actually pops into your head? For a lot of us, it's, total sci-fi fantasy. Just picture it. A highly advanced machine casually strolling through your kitchen, organizing your cupboards exactly how you like them, and then seamlessly serving up a completely customized cup of coffee for every single person in your house. Sounds like a dream that would make mornings a whole lot easier, doesn't it? But before we get too lost in the idea of having our own personal robotic butlers, we really need to ground ourselves in reality. We aren't just sitting around waiting for AI to arrive in the future. It is already deeply, deeply embedded in our present. Because while we're all busy dreaming of physical humanoid robots bringing us our morning brew, AI is secretly, quietly running the mundane aspects of our daily lives through incredibly complex, invisible algorithms. It's working inside your smartphone right now to optimize your battery life. It's actively assisting in modern cars to keep you safely in your lane. It's the invisible hand curating your social media feeds so you stay scrolling. It governs the behaviors of NPCs in your video games, flags fraudulent transactions in your banking apps, and even monitors security through advanced surveillance systems. It is quite literally everywhere, just humming quietly in the background. Now, what's really interesting about this is if we strip away all that magic, the cold, hard mechanics are pretty straightforward. Artificial intelligence is simply machines artificially incorporated with human-like intelligence to perform tasks as we do. That's really it. Fundamentally, it's just highly advanced math designed to mimic human behavior and decision-making. Let's move into section 1, the robot's learning journey. To really get a grip on this, imagine we just drop a brand new, super capable robot right into the middle of an unpredictable outdoor field. Okay, so what happens next? Well, step 1. Despite variations in the lighting, the landscape, and the totally unpredictable dimensions of the terrain, our robot has to perform as expected. This absolutely crucial ability to react appropriately to a completely new situation is called generalized learning. Next, our robot wanders to a crossroad. One path is smoothly paved, the other is steep and rocky. The robot has to evaluate its own capabilities and determine which path to take based on its present circumstances. This portrays the robot's reasoning ability. Finally, after a short stroll down that paved path, the robot hits a rushing stream. It can't just swim across. But it looks around, spots a plank of wood provided in its environment, lays it across the water, and walks right over. It used a given input to solve an unexpected hurdle. And that right there is problem solving. So, the absolutely crucial point here is that these 3 specific steps, generalized learning, reasoning, and problem solving, are exactly the capabilities that make our theoretical robot artificially intelligent. It's not magic, it's a highly systematic process. In short, AI provides machines with the capability to adapt to their environment, reason through their options, and ultimately provide real solutions to the tasks they're given. Section 2. Weak AI versus strong AI. We really need to shatter some common misconceptions here, so let's break AI down into 2 main camps. First up, weak AI, also known as narrow AI. This focuses solely on one specific task. For example, there's a famous AI program called AlphaGo, and it is an absolute maestro at the highly complex board game Go, like easily defeating human world champions. But you absolutely cannot expect AlphaGo to be even remotely good at chess. It simply doesn't know how. Its intelligence is incredibly narrow. On the flip side, we have strong AI. This would be a machine that is entirely self-aware, one that eventually develops real emotions, making its responses totally unpredictable. Think of characters like Ultron from the Avengers. Strong AI is super fascinating, but it currently exists strictly in the realm of fiction. Now, I know exactly what some of you are thinking. You're looking at your smart speaker at home and going, wait a minute, my virtual assistant can tell me the weather, play music, and set my alarms. That's multiple tasks, so it's got to be strong AI, right? Well, actually, scratch that. It's not exactly how it works, and this brilliantly illustrates the difference. When you ask it to play a song, let's say Despacito, the AI doesn't actually understand music or your human desire to hear a catchy tune. It simply picks up the audio keywords play and Despacito, and it runs a program it was specifically trained to execute. Try asking that same assistant a highly specific, complex question it hasn't been programmed for, like the exact real-time traffic status from your unique workplace to your home right this very second, assuming you haven't given it those parameters. It can't do it. Keyword recognition is a far cry from generalized, self-aware thinking. Let's move to Section 3, the AI family tree, and see how this all builds. People throw around terms like artificial intelligence, machine learning, and deep learning like they're the exact same thing. They're not. While AI is the overarching concept, machine learning, or ML, is the specific technique used to actually achieve that artificial intelligence. It provides a machine with the capability to learn from raw data and past experience through complex algorithms, rather than having a human sit there and manually program every single rule into it. Then, going one step deeper down that family tree, we hit deep learning, or DL. This is a subset of machine learning, but what makes deep learning so incredibly fascinating is that the learning is done through neural networks. These are structures directly inspired by the biological architecture of the human brain. This multi-layered approach means that incredibly massive amounts of data and highly complex patterns, things like recognizing faces in a crowded room or translating languages in real time, can be perceived and processed far, far more accurately. Which brings us to Section 4, the future of AI. So where is all this biological mimicking actually taking us? Because the human brain itself is still kind of a massive mystery to modern science. AI literally has entire unventured domains left to explore as the tech matures, and the possibilities are staggering. Futurist Ray Kurzweil predicts that by the year 2045, we are going to reach what's known as the point of singularity. This is the theoretical moment in time where we will finally have robots and artificial systems that are exactly as smart, if not smarter, than human beings across the board. Just let that sink in for a second. 2045. And hey, if that wasn't mind-bending enough for you, Elon Musk anticipates a future where the human mind and body will literally be enhanced by physical AI implants, effectively merging us with our technology and making us partly cyborgs. It's a wildly provocative thought, isn't it? Whether it sounds like a utopian dream or a sci-fi thriller to you, it really highlights just how deeply integrated AI might become with our very humanity in the years to come. To wrap up our explainer today, I want to leave you with a quick challenge. Let's see how much the line between science fiction and reality has already blurred for you. Which of these AI projects do you think does not exist yet? Is it A, an AI robot that has actually been granted legal citizenship? Is it B, a robot built with a functioning musculoskeletal system? Is it C, an AI that can accurately read its owner's emotional state? Or is it D, an AI that genuinely develops its own emotions over time? Give it some deep thought. I highly encourage you to discuss and drop your answers in the comments. The answer might totally surprise you and show you exactly how close we already are to the future. Thank you so much for joining me to demystify AI today. Keep learning, and I'll see you in the next explainer.